Computing standard deviation by hand is a little bit cumbersome, but as long as the data set's not too big, it's a really good idea to do at least a couple of standard deviation calculations by hand, because it really helps you to get more perspective on what the standard deviation actually means. The best way to describe standard deviation is this is not exactly correct, but it's more or less the average of all the distances away from the mean of the values in the data set. So if we're going to compute the standard deviation for the four weights of the dogs in the first picture, which are 70, 73, 58, and 60, first thing we need to do is find the mean. So we'll kind of do that off to the side. The mean, of course, is going to come from adding the four weights together. And dividing by how many there are, which is 4. And that mean works out to be 65.25 pounds. Now, the way we're going to compute our standard deviation is we'll start by listing our data values, 70, 73, 58, and 60. We will subtract each minus the mean to see how far away each is from the mean. So first we have 70 minus 65.25, which is 4.75. That's how many pounds away from the mean the 70-pound dog is. 73 minus the mean is 7.75. 58 minus the mean is negative 7.25. And 60 minus the mean is negative 5.25. If all we do is average these things, we're always going to get 0. You can try it if you want, but I promise these will always add up to 0. And one way we can fix that is by squaring these results. That's going to make them all positive. It also makes them too big, but we'll address that later. So 4.75 squared is 22.5625. 7.75 squared is 60.0625. Minus 7.25 squared is 52.5625. And minus 5.25 squared is 27.5625. Now I'm going to add all these results, and that works out to be 162.75. What I'm essentially doing here is finding the average of these numbers, or the mean. You would think I'd divide by 4, but in computing standard deviation from a sample, we actually divide by 1 less than the number of values. So we divide by 3 and get 54.25. That's close to, or sort of, the average of the squares of the distances away from the mean. But what we want to know is the average of the actual distances away from the mean. So we, in some sense, undo the square we did earlier by computing a square root. That gives us 7.37 pounds, and that is the standard deviation for this data set. Now, the standard deviation was computed for the dogs in the second picture to be 30.7 pounds. The reason that makes so much more sense is because all the dogs in the first picture are of similar size and similar weight, so you wouldn't expect the variation among them to be that big, and it's not. But in the second picture, there's some really big dogs, some very small dogs. You can see just by looking at the weights, there's a lot more variation. And so any measure that measures how much variation there is certainly should give us a bigger number for the second picture. And so the fact that it's 30.7 pounds compared to 7.37 pounds absolutely makes sense.